record on the cloud. I have started recording in the cloud. Let me open blank pages, couple of blank pages in there. Okay. Okay. Now, this is the Python. These are all packages that I have to import to the Python environment. NLTK. On the line number 2, NL means natural language. Okay. So the way we speak all the time, that language is called the natural language. Okay. And TK means toolkit. Natural language toolkit has been imported, and from natural language toolkit, we also import tokenizing, which I'm going to discuss later. And then Panda is a famous package which has been imported, and finally operating system has been imported as well. Now let me see what is the directory. Directory is this one, but we want to change the directory as the download folder. If we go to the download folder, and this is Barack Obama, let me go there and find a directory or location or path, which I have changed it in here in this format. Okay. This has been changed. Now let me change backward slash to forward slash. Backward slash to forward slash. Okay. This has been changed. Now I want to do these things. Okay. So now, are you seeing? Let me show you what is BO. This is the BO. Okay, this is his inaugural speech. There are 2 inaugural speech. Both of these things, I think it is in here. Yeah, these are all is in here. This is his second speech. Okay, Vice President Biden, Miss Chief Justice, member of the United States Congress, distinguished guests and fellow citizens. This is his second speech. This is his first speech. First speech like this way. So I copy and paste it from there and make it as a text file. Clear? So how to import the text data, that is what you are learning on the line number 11. But before running the line number 11, you have to declare line number 9, which is the directory or path name of where your data is saved. And then, of course, those packages from line 2, line 5 must be imported. Okay. So now see, if you run this, so if you run this now, so your data has been run. Okay. Data has been run. So Obama's entire text data has been imported. Now, are you seeing what does that mean? UTF-8. UTF-8, they contain more than 1.1 million characters. They can transfer this. Okay. For example, suppose you are writing something in your own language, right? And in that language, you put some of the words that are actually original English word. He is writing something in his own languages, but when he writing something, some English word he wrote in his languages. Okay. So those type of character, how can we identify? So that UTF-8 they can hold altogether 1.1 million characters, something like this. Understand? More than like that. For example, if I show you what does this means, quickly you will understand what they will do, because during the entire speech, if there is any special character showed up, then by this package they can easily identify. For example, take a look at that. What does this mean? This is called UCS transformation format 8, and then there is a Wikipedia come in there, and then take a look at this. Are you seeing? This is a first quote, this is the last quote point, and this is the byte like this way. So for example, there is a specific example of a character that I want to see. For example, see, this $sign has this type of code. Okay, and it is a binary code point like this way. So in the speech, if it is read, any type of character is found, then that could be handled like that way. So what is the actual figure? So UFT capable of encoding that many valid Unicode code points using 1 to 4 bytes of the disk. So that many. If you click on there, then you will see what does that mean. So that means they are highlighting these things at the planes this. Okay. So that is enough discussions about that. After doing this, now if I write here file, we are not seeing anything, but if I read it, it is just open. But now if I read it, after reading these things, then if I write here line 1, here is the entire speech we are seeing. Okay. So what is the difference? 11 is just opening bo.text. So that means when I declare directory on line number 9, and then line number 11, I'm just opening that one with the encoding UTF-8 in the entire speech. If there is any special characteristics that can be converted in certain amicable certain format, amicable format, so that we can do the analysis. And in order to see his speech, we have to read the file which we are doing on the line number 12. Okay. So after doing these things, now I said I'm going to explain what is tokenization. You have a question? What is question? This is not opening? Okay. If you did not read it, you have to read it. So that is why I said, after doing that, now if you write here line 1. So without reading, it would not open. So what I discussed in there, the line number is 11 is not enough to see the text that we want to bring. That is just opening. Okay, that is just opening, but it needs to be read, and which could be done by running the line number 12. Clear? Okay, which could be done by running line number 12. I says token, right? So token means what? Token means, suppose you want to get some food that is free or cheap, then they have decided, the restaurant owner, they will give you some token, right? Without token, you cannot get this, right? I clearly wrote, tokenization is the process of breaking up a given text into units called tokens. So that means tokenization, they will do what? In big text, they will divide into sentences or even words. Understand? So that is why the tokenization. Now we have big speeches. If I run the tokenizations, then see how it will look like. So tokenization is the process of breaking up a given text into units called tokens. Tokens can be individual words, phrases, or even whole sentences. Now, after running these things, like line 2, when I run the line 2, when I ran the line 2, I got these things. So after that, if you write here line 2 is not defined. Okay, let me see why line 2 is not defined. They are saying, let me see. As it is just the tokenized, we need to put it in the format of a data frame. What? Line 2 is not defined. Tokenization did not run. Okay. Okay. That's fine. What are they saying? Import NLK download. Okay, so now that one they are saying. Let me see whether that one. Control V. Let me see. Now token 2. Now it is running. But in my computer, when I ran it, it was running fine. Now it is running because a package was not installed there. So now line 2. So are you seeing previously it was entire speech. Now they break it into pieces. Are you seeing each is a sentence, right? So what we had an entire speech. By tokenizing, we break it in, we break it into sentences. Okay. After that, now I run it in a very beautiful format, data frame format. In the data frame format, if I run the data frame format, are you seeing now? I am seeing entire speech on a number of sentences. How many sentences are in there? If I want to check that things, I have to import numpy as np. Yes.
Line 2 is not running here.
Line 2 is not running?
Yeah.
So what do you have to do? What did I do? I imported this package. Import this. Import this. Okay. Now it is working?
Yeah.
Now, so far, it's not working? Line number 6, run. NLTK.download. NLTK.download. Okay, so control enter. Okay, so now it is working. So this, then that. Okay. Clear, right? So now after running that, when we run the line number 24, we got this very beautiful thing, right? Line number 24, we got this very beautiful thing, line 3. So if you want to see the line 3 files, line 3, what is the line 3? Are you seeing? All is coming in the format of a line. 218 lines. It was a speech. It was a combination of two inaugural speeches by President Obama. Okay. So now by tokenizing what I did, all the two speeches, all the sentences, I make it in this format. Now you see this is a row number and this is his text. Okay. This is one format, could be done. What did you say? Everything together means?
How did you get it?
How did I get the?
What should I now? Yeah.
Okay, I go to the variable explorer. Okay,
Oh, yeah.
variable explorer and the line 3, I got it from there. Now transforming everything in lowercase. Okay, we are doing text mining, right? So sometimes some letter starts with the capital letter and some same letter, America can start with a small letter, America can start with the capital letter, right? So you understand small letter and capital letter, right? Good questions. Why do you have to do this? Because in your speech, suppose the word good is a good word, right? Good is a good word. So the word good comes once in the letter, small letter format. Another one come in is a capital letter format. So that means two different character. They will say that, well, this is two different word. When you will find the frequently appearing word, they will come the letter good appearing with the small letter 10 times, letter good with the capital letter at the font comes 7 times. But actually they are the same thing. So I want to see them all together. They are appearing 17 times. In order to do that, you have to transfer uppercase to lowercase. All words now will be transferred to from uppercase to lowercase. Okay. So now see one line of code in here. See, DF was the data, right? So now DF was my data. So line 3, now in the line 3 dot columns, I am adding a title in there. Are you seeing there is 0 written, right? 0. So 0 column, 0 means 0 column. This 0 will disappear. I want to write here txt text. That is what I am doing, line number 26. Line number 26, it will have now text. Okay. So I put here, I run this one. And now if you take a look at the previous one, now see, it appears text, right? I named the column as a text. Previously it was 0. On the line number 26. Then I just want to take a look at the I give line number 3 as a name df head, and then now what I am doing on the line number 26 df, and then within text I am taking df text x.string dot stream dot lower. So that means from DF, I'm taking the column this, I'm making it as a lower. Currently, see, my fellow M starts with the big. That is start with the big letter. FOR, big letter, right? Capital letter or big letter. So now after running this, now if you take a look, take a look, everything becomes small letter now. Previously, this M was capital letter, now it is small letter. Okay? Entire speech, everything now small letter. So far good. So you have to run this line of code, but now your major task is to import the data. Import the data from where? For the State of the Union address of the US President after bringing that. That means 8 State of the Union addresses of Barack Obama, 8 State of the Union addresses of Reagan, 8 State of the Union addresses of Bill Clinton, and 8 from George Bush. Yeah, right? You have to bring those things. After bringing these things, run this line of code. Okay, so now expressing each sentence to a number of words. I want to, each sentence now I want to express in a number of words. This is what from NLTK tokenize, import a regular expression for tokenizer. So regular expression tokenizer, I want to run this regular expression tokenizer, these things I am going to apply in there. Take a look at this one. I am going to apply in here. And then after that, I'm using tokenize, applying these things on that. df.text, I am applying these things, tokenizations. Now, if you take a look at that, previously, this was my fellow citizens, this, right? And I. So that means these things has been gone. This like the colon marks has been gone. This is no longer is in there. How are you seeing regular expressions? That regular expressions separate the word and rest of the thing they do not, because I is a first person, right? It is used in the speeches sentences. I did it, right? But the and those things are not used, so that is not in here. So what I want to tell you, after running these packages and these regular expression tokenizer, when you do these things and that things, regular expression tokenize, you are applying these things on that data. What they will do, each sentences is now separated in the format of a word by a separations by comma, and we give a name of it. The name of this new column is text token. Text token is the name of the new column. You're seeing that, right? Right. So now the data has 2 columns. If you take a look at that, np dot shape, and then if you write df, it has now 219 row and 2 columns. So sentences has been transferred to a new column consisting of all the relevant words. Okay. Now, there is a thing called the stop words. Is everyone okay? Are you understanding? Okay, yes,
So, when I learned that, my-
line number,
the last one, you know,
okay, the line number 32,
where it has my text token.
text token, 32. Yeah, so it is not running?
Look, it's actually run for like, what, it switched, like the text and text token, like they switch each other places.
So what they are doing there, text was this column, right?
Yeah,
Text was this column, right?
yeah,
So the line number from the DF data takes the text column and apply regular expression tokenize. So the apply regular expression, these are the keyword. I am applying these things on DF so that each sentences become now each word separated by comma.
can I show you?
Your one is different than mine.
I did the same thing, but right now, probably is my system. I don't know. So yeah, my comma, yeah, is showing as text, and the text token is showing as, yeah.
You are getting exactly the same thing as I get.
No, not so. No.
What?
Yeah.
Yeah, it shows. Because your window is small, so that is why you cannot see. Okay. So after doing this, now what is stop word? What is stop word? In stop word means in English literature. So you definitely learn when you are in the middle school part of speech, right? Noun, pronoun, verb, adverb, adjective, preposition, conjunction, interjections. So preposition in, of, are, and then or, all of these, and then indefinite and definite article a, the, right? So when I do the sentiment analysis, if the definite article the appears 100 times, that does not make sense, right? If indefinite article a and appearing, if number of times like 50 times preposition of appearing, we do not need that, right? So those are the words, they are called the stop words. So colon, semicolon, and then apostrophe, and then comma, and period. All of this I want to kick out from the speech. Understand? That is what known as the stop words. Now I said stop words. If I run this, and then next time I run this download stop words, and then from there, if I do these are all packages. Now, if you want to see Nature Toolkit corpus.stopwords.english. In English literature, what are the stop words? Those packages or dictionary they have created. After creating this, if you write the stop words, these are the all stop words. Line 44, if you run, you will find these are the stop words. Understand? These are the stop words. So these are the stop words. 179 stop words. Are you understanding? So in the speech, if these stop words are in there, I want to delete them. I want them to be kicked out. So you understand stop words, right? Preposition, conjunction, interjections like some words, blah, blah. These are the things. If you want to avoid, these are the things. Now the question is, suppose in the speech, I have identified few words that is not in the stop words. Okay, that is not. I can create my own stop words and add that. This is the most important thing. My stop words on the line number 46, I am adding HTTP, and then I have added blah blah. I have added CCU, CQ. Okay, and then after declaring those things, I am appending it. I am connecting it with the original stop words. So I put here stop words on the line number 43, stop words, line number 43. This is the stop words, and then these stop words I am appending, I am extending, I am adding, extending these stop words. Okay, for here you can add few more. Okay, suppose America got a president who was American citizen, born in USA, but raised up in, suppose, Germany or maybe Argentina. Okay, so up until 15 years, he lived there and then came to USA. But he knows some Argentine language, Spanish language. During his inauguration speech, he gave some Spanish word. Okay, those things comes here, then you can add those things in this format and you can delete this. Understand? Okay. Now I want to remove stop words. Okay, so take a look at that. My column was text, and from the text I created text token, right? That was my original column text, and then this is my text token. On this I will apply stop words to get it to clean each line. Clear? So what I'm doing now, remove stop words. DF is my data frame, and in the data frame I take the text underscore token. Text underscore token I have taken, and then DF text underscore token I am applying. Applying here lambda. Lambda is a keyword in R. You are familiar with the R? Do you remember in the R when we write apply, then immediately we write the function? Remember that thing? Apply, apply, when we use these things, then immediately after that we write the functions. Here apply, instead of function they wrote lambda. So that means function of X. What is X? X is text token. X is text token. Item for item in X if item not in the stop words. Understand? So here X means that text token. So I'm doing apply function in there so that the text token will not have any stop words in there. So run it. I am running it. After running it, then I am taking the head, text token. See the difference. Previously, text token has a new name, right? Now it does not have. So how about, let me change it to that. Text token, stop words remove. Let me write it like this way. Stop word removed. Stop word removed. If you write like this way, if you write like this way, and DF has been created already. So let me go to the here. If I come from there, then it will okay. And then take a look at that. So stop word removed, okay? Stop word removed has been created from text token. So previously it was a my fellow and all of those everything is removed. Okay. I need to take out these things. Okay. Let me do all of these things quickly so that there would not be any issue. Okay. Now I want to do remove infrequently used word. So our purpose is to see the words who are appearing more frequently. For example, the word that is appearing 1 or 2 times, we do not want to have them. So we first change the format of the text underscore token to string and keep only words which are longer than 2 letters. Okay. So import pandas. And then line number 56 is telling you, I want to see a maximum number of 5 columns. And I also want to see a maximum number of maybe 20 rows from the data sets. In this case, if I set it to 20, each time I want to see the output, then I will see the output as well. Now, in the 58, what I am doing in here, again, text token is my this thing. In this speech, if there is any word that consists of 2 letters, that should be removed in here. For example, apply lambda x dot join item for item in X if length of the item is greater than 2. So that means length of the item is greater than 2, that should be kept. Okay, that is known as this. I am giving it as a name like this. Okay, I'm giving it as a name like this. So if I run this, you will see these things: text, text token, text string. In this case, text string, any comma that is in there which has been kicked out. So no comma stays there. Okay. So now create a list of all words. Now I want to, from there, I want to create a list of all words. So all of these words will be put together. See what I did, dot join, and then word for word in the df.text string. In this, df is the name of the data frame and text string is the name of the column. So I am taking text string column from the df data, and then word for word in this, I'm joining all the words there. Take a look at that. If I run this and then want to find the length of all words, then see what I get, 15,696 words. In Obama's 2 speeches, after deleting all stop words, all preposition, conjunction, interjections, unnecessary word, and the word that are length of 2, I am getting in the entire speech now 15,696 word. If I write like this way, all underscore words, then I will get all the words like this way. If someone read this word, he will not understand. Fellow citizen, stand today humble task, grateful trust, bestowed, mindful sacrifices born, right? All prepositions, conjunction, interjections, noun, pronoun has been taken away, right? Clear?
Yeah.
Excuse me, Professor. Excuse me, Professor.
After doing this, tokenized words, all words, I am tokenizing this. Now, if you take a look at these tokenized words now, so tokenized means now all the word are now separated. Previously, you see just the word, now each word is separated, right? Tokenization means when I first discussed tokenizations, you see each piece was in their speech and they are separated as the sentences, right? After the sentences, what I did, we transfer it to the word, and then from there we get rid of all stop words, and after getting rid of the all stop words, the words that we have, we combine them. Now again we apply tokenizations. Each word is now separated. Okay, now take a look at the frequency. I want to see which word is coming more frequently. Okay, on the line number 70, the tokenized words, I want to see frequency distribution. Okay, I am doing frequency distributions. And then if I write this, I see frequency distributions. The word applause comes 25. Okay, the word applause comes 25. So president says sometimes like, I applaud my election team who work hard for me to win these elections. And immediately people started clapping, right? And then they are also included that things. Because applause means not only just Obama said applause multiple times. Okay? Then it was added in there. And then next one is coming mask 24 times. Nation is coming 18 times. America is coming 18 times. People is coming 18 times. New is coming 17 times. Time is coming 16. Every coming 15. Today is coming 13. Can came 12. Okay. Some of this word we can also remove. For example, can. Yeah, we can remove can, something like that. Now I want to drop less frequently used word. The word that are used only one time, I don't want to keep that word. How can I do that? Are you seeing at the last of the line number 73, getter equal to 1? The word that is coming only one time, I am avoiding that thing. So let me show you. So text underscore string underscore frequency distributions. From there, DF is the original data frame where text underscore token, and then I am applying lambda x, and then I am joining them, joining item for item in X if F distributions that is coming from there that we have created there. F distributions is the frequency. If frequency in the item getter equal to 1, I only pick the item, okay? So if you run this, and then if you run that one, here you will see, let me find the difference between these two. So let me try to find another thing. That is text string F distributions, right? Now let me see one thing, whether they found or not. So this is the DF length DF dot text underscore string. It's not length, it's length. In the R, it is length 219. Okay. So what I did, I have to actually find it for that one. Text string string text string underscore F dest. F is text string underscore F dest. Text string underscore F. No, it is the column, right? Okay, so it is the column. I have to combine them in order to find a word that it will not work the way I'm looking. So the way I'm looking, so what I wanted to do, I wanted to combine all of this and want to check the length of this. I want to combine all of this and want to check the length of this, which we did before. But let's see, down the road we can do this thing. So now I want to, so now this is the important thing. Lemmatizations. Have you heard the name lemma? Lemma? There is a theory, right? Or theorem. Okay. In order to prove the theorem, they do what? Lemma. Now you remember? So lemma means a small assumption or axiom or some small conditions that we want to do in order to prove the theorem. For example, America could be written US, America could be written America. America could be written America. Riga. America could be written American. America could be written United States. It could be written US, something like that, US, right? So lemmatization is doing what? Suppose kindness, right? There are many words that has a different kinds of civilization, uncivil, right? How can I find one word that will have many? Interested, interesting, interest. Okay. You will find some English word that has different format. Okay. It has a noun format, it has an adjective format, it has a adverb format. Okay. It has a those are the things. So lemmatization is doing what? They are picking the main word by removing all others. Okay. For example, if there is a interesting, interested, not interested, uninterested, uninterested, interested, non-interested. Okay. All of these things, if coming together, so they will pick the main part of the word. Understand? So they will take the not uninterested. Uninterested is different. But if there is a three word, interested, interesting, interest. Suppose three. Interested, interesting, interest. If this is the scenario, they will pick only one, interest. So lemmatization does these things. Now we are doing this one and that one. These are some packages, and then we are doing this, and then we are declaring the lemmatizer. We are declaring lemmatizer. So DF now is text string lemmatizing. I am applying it on the text string F distribution. Apply word nat lam dot lemmatize. So this is the word nat lemmatizer. As the keyword, I have learned like this, and then I have applied it in there. Okay. So what lemmatizing is doing, if there is a different format of a word which are known as the adjective, noun, or past present participle, or something like that, past tense, something like that, they will make it only the main word. Okay. So let me run these things then. Okay. After doing these things, now we want to check one important thing. Let me write the data in here. df dot head. df dot head, when I write, after lemmatizing, I got this. Before lemmatizing, I got this one, text string F distribution. I want to check whether this and that has the same number of words or not. So how can I do that? So this is the way we can see the maximum number of pd dot set underscore options, and then within quotation display dot maximum rows, comma 20. And then within that, we can find df and these conditions. So for the first variable and the second variable, whether there are the same number of things or not. So I'm creating a is equal variable. So if I run these things, I got this. So now I will find a true, true, true. df dot head, new column has been created that has a true, 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 true. So that means text string lemmatized and text string f frequency distribution has the same number if there is true. If they are not true, then there is a difference. Now I want to see actual count. Is dot equal dot values counts. I am counting in here. There is 219. So there is not anything like is equal yes true. So all of these are true. So that means two variables that I have created on the column text string f distribution and text string lemmatizations who have the same number of entries. Okay. So these are just some, now I am going to start doing some text mining analysis. Okay. First of all, let me see whether this will be done. I am now importing, inserting a Conda package in there. It will take few minutes on the line number 100. The online student Omoni, can you hear me?
Yeah, I can, Professor.
I cannot hear you. Can you hear me? Let me see.
I can hear you, Professor.
Omoni, if you are allowed to take my class remotely, that's fine. But if you are not, then you have to come to the class, okay? Otherwise, university will punish me. Okay, then it's fine. 1 day or 2 day, there is options that is okay. But university department director and other told me, okay, thank you very much. That will be a document. I sent you a email. Yeah. So send me an email so that I can show that, because university is a very strict policy. And then otherwise they said, well, Muhammad, you are giving preference to one person and not other. Okay. Thank you very much for clarifying. Thank you very much. Okay. So now I ran the line number 100. Now I want to do these packages I ran now. Okay, after packaging run now, all words lamb, all words lamb. So this is the all words lamb join word for word in DF like this. This is the all words I'm joining. Okay. So after lemmatizing, I join all the word. If you take a look at this, all underscore words underscore lem. And then if I want to find here, len, how many words are in there? I just want to find it. 15,612 words in there. Okay. So now, if I want to do these things, the plot, this is the plot I got in here. Okay. From there, which font size is bigger or biggest?
Must.
Must, right?
Yeah.
Or applause?
Applause.
Applause or must or applause? Okay, that is the way you can do the word cloud. Okay, let me tell you, these are all ideas generated in last 10 to 12 years ago, 13 years ago. When I came to US in 2006 for my higher study, I did not hear about text mining or NLP, because when internet started booming and online business started to grow, people started to buy things and people started to comment, and lot of text data was generated, Airbnb, and then Amazon product, they are making comments. So they are scientists, data scientists, and they started to think that what should we do? How can we analyze this data? Understand? So that's why this NLP, natural languages, everything appeared. These are very recent, 10, 15 years ago, this has been developed. Okay, there are a lot of development is going on. Computer science, mathematician, statistician, they are working together to do all of these things. What I am teaching now, I never thought in like 12 years, 10 years ago that I'm going to teach these things. Okay, I never thought about these things that I'm going to teach these things. So now, if I want to find a different kind of picture, so this is a different kinds of things. Another picture, okay? Okay. In one circle, they have put these things. So they said that, well, at least first 3 words are good word, right? Must, applause, nations. So from this word, we have to find some words that are neutral, some words that are positive, and some words that are negative. From those things, we want to do the sentiment analysis. Okay, so now I want to see the frequency distributions. So now these are the packages, and after that, if I run this, I got this. And from there, if I write FD, most commonly used 3 words, applause is appearing 25, must is 24. Okay. So applause is more time appearing, right? So if you write it in the tabulate format, it will show like this way. And then come here, if you go there, put here 10, then it is 10 most frequently used word are Applause is appearing 25, mast is appearing 24, nation is appearing 18 times, America is appearing 18, people is appearing 18, new is appearing 17 times, time is appearing 16, every is appearing 15, today is appearing 13, generation is appearing 11 times. Most frequently used 10 words. If you want to take a look at it, most frequently used 20 words, then it should be that 20 words. Understand? I want to do the bar plot of the most frequently used 10 words. This is the bar plot of the most frequently used 10 word. Okay. This is the bar plot. So now I want to see a specific word. Americans is appearing 7 times. Show frequency of a specific word. FD is my data. From there, I want to take a Americans. American is appearing. Now I want to do the sentiment analysis. In order to do the sentiment analysis, I have to download some of the packages. After that, I see from nltk.sentiment, import sentiment, intensity analyzer. Now I want to find polarity. Let me spend. So sentiment analysis means what? United States President give the speech to the nations as well as to the rest of the world, right? So in his word, he said, America has a hope, America will prosper more, we'll try our best to keep America safe. If you mess up with the America, we have a long memory, right? So that means they are saying long memory. Long memory is usually a good word, but it was used in this sense as a bad, right? As a threatening one, right? Understand? So how many words are positive? How many words are negative? How many are neutral? That should be identified by the package analyzer, sentiment intensity analyzer. So what I did in here, I am creating a column polarity. I am creating a column polarity from the text string lemmatizing column, and I am applying here function X. X stands for text string lemmatizer analyzer dot polarity underscore, and then we are putting a score there. It is all of these things is using the sentiment analysis 175 analyzer. I am putting here analyzer dot polarity dot x. This x is the argument for the function lambda. Lambda is a function for the apply function lambda. This x denote these things. That's the way you write the R function, okay? So now let us do these things. I have done these things. Now take a look at the tail, and then take a look at the head also. If I want to take a look at the head, tan head. So now what they will go. So this is the This is the in the tokeni text string lemmatized, they are creating polarity. Polarity has negative, neutral, and positive. And then finally, this is a compound. Compound means a combination of all of these. They are doing a compound analysis in here. Understand? Take a look at that. 0 row. So that means this is the row. This is the row. 0 row. So 0, 1, 2, 3, 4, 5, 6. 6 row has just this square bracket and 7, 8, 9. And then they go there. They find their negative equal to 0, neutral equal to this, positive equal to this, and compound. Entire line they have analyzed. This found some negative. In that line, negative is 0, but in this line, line number 4, negative equal to 0.274. Okay, here line number 4, 0.766, and positive is 0, and composite something like that way. So these are the values is coming from sentiment analysis. They go through each word, corresponding to each word, they put a score, and then when they find this score, when they find that word in the text, they assign those predetermined sentiment analysis score, and finally compute these things. You understand, right? So one sentence, there could have positive word, negative word, and good word. So how do you know which one positive, which one good? The people who develop packages, they analyze all the English dictionary, and then they said, well, these are the words we will put as a neutral, and these are the words we could put as a positive. These are the words we can put as a negative. But there is a difference. Why? Sometimes if you say something in a negative way, negation way, he is not a good person. But if you take out the not, then what will happen? So that means when you analyze the data, then good should appear 7 times, but because of these negations, you are also including that good. Understand? So President said in his speech, we United States America always help people around the world when there is a famine, there is a natural disaster, something like that. But if you mess up with USA, we have a long memory. Long memory is a good word, but in this case, it was used in a bad sense, right? So when you do the sentiment analysis, if there is a tons of text, you do not have a proper knowledge, you might end up with some 5%, 7% wrong thing. Understand? Unless otherwise you are very careful. If you said that, well, if long memory is in one word, then let us change long memory as a bad word, because the way he phrased these things. So now, change the data structure. Now I want to change the data structure and then see how it will work. df dot polarity I am dropping in axis 1, and then I am df polarity apply pds dot series from polarity axis 1, and then finally you will see how it looks like. Now see, I'm dropping that one. Now here I have, if I put they are saying positive and compound, and there is also negative and neutral one. So let me see if I can do that one. PD dot set option. Where was it? PD dot set options. This is the code I always forget. PD dot set option. Come. Here. PD dot set options, copy, display. Oh. What did I write? Columns. Now see, I see the maximum columns of 20 on line number 85. Now take a look at that. So this is the data I want to like df dot head. This is the original text, that is the tokenized, that is the token string, that is the text string frequency distribution. This is the lemmatizing, and lemmatizing. After that, I created like lemmatize and tokenize fed. These two has exactly same matching or not. That is what is created by the column is equal is comparing whether this line and that line has the exactly same word. That is true, true, true. Yes. So now see, I created for each line, I created negative, negative, neutral, positive, and compound. So this is the compound score. Based on that, we are going to analyze sentiment analysis. Okay. So all of these things is coming from the package that we install and run. Clear? Okay, after that, if I want to see the sentiment, so sentiment on the basis of that, they are putting sentiment positive and negative. So let me again show you df dot head. In this case, if I want to find copy, just let me change it to the rows, and I want to see maximum of 20 rows. RO WS rows. Let me put here 40 rows. Let me run it, and after running that, I want to run all of this. And to run this, and then head, I want to put here suppose 50. Now I want to explain something from there. 50 rows I have set up in there. Are you seeing? So when compound, there is a negative value, then this is a negative sentiment. If there is a zero value, then neutral. Positive value, that means there is a positive sentiment. Understand, right? So this is coming from the compound value which combines positive, negative, and then a neutral. Each line, they have computed these things. Clear, right?
189. Not right here.
189 is not running?
Yeah.
Okay, so let me see.
It's creating variables next to the
Which one? 188?
creating variable.
Yeah, 188.
188 is not running?
Yeah.
But it is running for me. So highest, maybe your computer need to restart. So this is the, maybe. It is running for me. What else I can do? No, listen. if like few of you are running, but I have to tell you the truth. Sometimes it's happened when I have seen in the R and Python programming, sometimes it is not running, doing all of these things. And then if you restart the computer, it will start again.
Sir.
Yes. Sorry? Your picture looks good.
What about you? You don't have anything.
Yes.
And I think that's the reason why when it's happening,
So highest positive sentiment you can find like this way, and highest negative sentiments you can find like this way. And these are some line plots. What? Okay, so let me see. Line plot. Found. Here is the sentiment analysis.
Oh my God.
So what line I missed? So you can write down it this one. So the line number 204, right?
Yes.
So you have to change this one. Are you seeing SNS counter plot? These things it matches, but this line I just created. You change it to your code. Otherwise, you have a problem of getting this type of sentiment analysis. So in this case, I say Obama's speech, the line or spike above zero is higher compared to the line or spike below the zero line. Understand? Line 204. Can you see the line 204? Create that line. Otherwise, like the line number 206 to the rest will not work.
So can you go back to?
If you want to do the box plot, it will look like this. Which one you want to? Let me drink little water, then I will do that.
Hello, Professor.
Okay. This is about discussions, everything in the data frame format, right? Are you seeing another one? Let me open another one. This is another one, okay? In this case, everything was analyzed on the basis of a text format instead of a data frame format. So let me run quickly these things. So this is the file that I have opened. This is the way it is read. And now immediately after running these things, let me show you. Pay some attention in here what I'm doing. I have opened now another one, text file underscore Barak Obama, okay? So in this case, I open the file, which is this, and then I read it, which is this. After reading these things, then line number 49, what I am doing, I'm splitting it. Now, if you take a look at this, 4,537 word is in there. Okay? This is another way. So previously it was in data frame format, 2 speeches. I make it as a 1 line, 2 line, up to 219 lines, something like that. But now it is just all the words. If you take a look at that, words, 1, this will be the all words. Okay? Now, this is just the words. Then from there words, word frequency without removing stop words. How can I find that? That is the way we can find the most frequently used word. Okay, I understand what you want. You want these things. And then you want all of these things. After doing these things, now you want that one counter. And now I see most frequently what the definite article D is appearing 221 times. And then conjunction and is appearing 192 times. Okay. So this is all words together. So now calling stop words English dictionary. So this is the stop words I call. And then I want to see first 5 stop words. This is the way first 5 stop words you can see. This is the first 5 stop words. Okay. Just want to see one thing. Okay. So now I have created a word for word in words 1 if word not in the stop words. So the words 1 is the all the words that I have in there. This is the all words. Okay. So now I said word for word in words 1 if word not in the stop word. So that means after running this, see, it will reduce significantly. So now 4,500 to it reduced to 2,456. Okay. Now from the string, I import these things. Here, what I am going to do, couple of function has been written. and then most frequently used word now, US. That US, and see, there is a small letter, capital letter, right?
Yeah.
Small letter, capital letter, that could be changed quickly. Most frequently used word, and then this is a string input punctuations, and replace, like the RE stands for the replace, replacing those things by this nothing. If these are the characteristics found in there, then it will be replaced by these in string A. A is my all words. Understand? A is the all words after removing stop words. Okay, so these are the all packages. It will take long time to install. And then I'm installing next one. Then next one, next one, next one. Okay, so it will take long time. So now see, this is the list of the stop words, set, stop words, English, and then punctuation link. Punctuation means these are the all punctuations, okay? This in your speech, if any of these characters is found, this is called the punctuation links, then you can remove punctuation mark for punctuation marks in the string dot punctuation. String is what? Whatever you have created as your data, okay? So now I want to remove a text. Remove text, a function has been created with these three argument: text, character list, full match word. And if condition is satisfied, then do this. If else condition satisfied, do this. Okay. Three function has been written, 3 or 4 functions. And then PPR speech. PPR speech mean if there is, you find these things, replace it by the blank space. If you find at the rate, replace it by this. If a speech is any format, that transfer it to the lowercase, uppercase or lowercase. This is what. And remove text. Remove text. You are going to use in there. This is a keyword. Remove text, which you have created in here. That function you are using in here. Okay. You created one function in there. If else conditions, that function you are using in here. And at the end, after creating, here is the punctuation links. Here is the number remover reps. This is the way it will return finally the speech that you are running through this procedure. Okay, functions you have created and you have a text that you are putting in the function, you are getting the output. Okay. Okay, so these are the couple of functions has been created, and then finally here I read the data. After reading the data, this is the clean text. Another function has been created. Remove text which was created before is applied on the speech line, and all of these things has been run over the given speeches, and finally give us the Obama data. So the Obama data, and finally we got in here line number. This is one speech is in here. It finishes in here, and we are checking how many lines in this data after running this. And then corpus. Corpus is means what? Corpus means collection of speeches sentence together. This is what the corpus means. So all the lines together making in one speech. That is the corpus is doing. Okay. In this case, corpus is doing, and then after doing these things, this is called the creative term document matrix. I think what the term document matrix is doing, if you run these things, so for example, suppose you will get altogether, suppose when you created the corpus, in the corpus, you suppose get line number 1, line number 2, 3, 4, 5, and suppose line number 50. 50 line you got, okay? Suppose you got 50 lines. Let me write here so that people in the online, they can also visit these things. What term document matrix means? Term documents term document matrix. Suppose after making the corpus means speeches or sentences together, made together in one speech. In that case, this is line number 1, line number 2, line number 3. That means sentence number 1, sentence number 2, up until all the sentence number 50. Okay. So suppose here you have found a word love. Suppose here you find the word hate. Suppose you had find the word oppression, right? And this is the word you find. And then if you find that oppression word in line number 3, then put there 1. If oppression is not found in the line number 1 and 2, 0, line number. How many you found? This is a 1 you will put. Understand? That is called the term document matrix. So this term document matrix is the fundamental for doing all cluster analysis classifications for the text data. Understand? So what term document matrix means? You have a corpus, that means collection of all sentences you put together and created one corpus, one speech. That corpus, that speech, that text document has suppose 50 lines, 50 sentences. 50 sentences you write, all the word you write in the row, all the 50 sentences you will write in the column, and then if the word appear in a particular column, that column you put 1, other column, if that word does not appear, you put 0. So then it will be a column matrix of 0 and 1. That is the fundamental for all classification clustering. Understand? So if you run these things, you will see there are a lot of beautiful things in there. That is the way term document matrix is created. And then we want to find get word associations. Get word association means what? America must is appearing suppose 70% of the time. Okay. So how many times compared to other it was appearing, you will give that as a percentage with respect to other, all total frequency. Understand? That is what called the word associations. After word associations, then what correlations you can find in there by running some functions in there. And in the same way, you will find word frequency and then bar plot. And finally, you will find word cloud. And then you find sentiment analysis. And then after sentiment analysis, there are some, I think, clustering as well as classifications things is in there. Understand? Clustering and classification is in there. So if you run these things, take time. it will generate your desired result. Understand? This is what I am running for the Barack Obama speech. So there is nothing to be worried about running these things. Now let me come to another point. Let me go to the announcement. This is the place I wanted you to do, right? This is the place I wanted to do. And I wanted 4 presidents, right?
Yeah.
4 presidents. So 4 presidency, Barack Obama has 2 unique identifier, 2013 to 2017, 2009 to 2013, right? So if I click in here and do the view page source, in this page source, if you come in here in this page source, yeah. So say, in this case, are you seeing it starts with the TR and it's S and with the TR, right? Are you seeing that? TR and TR. I already see some of the students already submitted the homework. So is TR and TR, in this case, are you seeing unique identifier in here? 2013 to 2017. From there, A and H reference, right? A and H reference, right? Take a look at the Python code. Faculty. Why all of this has been changed? So are you saying A and F, A and F, and then there was a span, right? This span is coming from there, or there is a span and class. It was in the original Georgia Tech class and these things. So in this case, you have to put 2009 to 2019, and you have to figure it out this one, what will be. And after doing these things, then if you run these things, you will find. But spend some time on there. Understand? Understand? So it is due by next Wednesday. So your responsibility is to import Barack Obama's 2009 to 2013 or 2013 to 2016, something like that. Okay. After importing those things, data is in there. Then 2 text mining thing I have shown to you today, right? One is data frame format. Another one I showed in the entire speech format. Data is not like in the data frame format. Data is a split format. So need to spend some time in there. So this is the place from where you will go, and you will have to find this. You have seen very clearly A and H references. A and H references these things, and Barack Obama is coming from here to there, 2013, right? So in this case, if you take a look at that, I use span and class. Okay, span and class. So here you will declare the URL, then here response dot contain all of this HTML parcher. Let me see. This is HTML, okay? This is HTML. Are you seeing? This is HTML. So from there, if you come in there, Biden, Donald Trump, and Barack Obama, from there, they have found their span and class. Instead of class, you can put here something like maybe TR you can put, or maybe you can put maybe TD you can put, or maybe TR you can put. and after putting TD, putting TD in here, TD, after putting TD and that, okay, or maybe TR and TD equal to this, you can put, combine these things in order to bring these four. Similarly, you can also bring his other speeches, okay? Here is his four speeches. Clear, you got it? This is very important. So play some game with these things. Why it's not working? Clear, right? Okay, so next class, I am going to discuss about simulations. I will give theoretical derivation sum and then go for using Python to derive how to simulate the data. So suppose you are doing work with a specific data. That specific data gives you a your desired result. Okay, whatever result you are expecting, that data give you your desired result. But that data could be well suited for a specific model. How can you validate? So you have to simulate the data 1000 times, and 1000 times you have to run this for your model, and when you do the average, and you will get your desired result. In that way, you can get your results. Okay. Most important announcement is that take serious preparations for your exam. How many questions are coming?
30.
How many minutes? 2 hours, 30 minutes. Okay. So that means 150 minutes. So all 3 Word documents make as a Word document, 1 Word document. Read each and everything and find where the code is in there. If it is not in your memory, then you will do all of these things. And when you sit in the exam, so all like 135 Python code should be in one file. And just at the top of that, you will read your data. Okay, and then find the problem number and change the data and change the variable name. Are you understanding? Otherwise, if you start to write it from the scratch, understand? No, it's open book, open note. I may. Should I tell a bad word? Should I tell a bad word?
No, I just have a question.
Yes.
So do we text mine what we did for web scraping?
Yeah.
Okay, is it?
So now, like what web scraping data you are bringing, that was the thing you will run like the text mining. That today I discussed bar chart, and then most frequently used word cloud sentiment analysis. These 4 things you will do.
Okay, so the one you just did, the text mining video.
Yeah.
We have to do.
On the imported data. You have to today what I discussed.
Everything.
4 things, right? 4 things I discussed. Word cloud, most frequently used word, bar chart of the most frequently used word, and then sentiment analysis. These 4 things, right? These 4 things I did. So the data that you will import, on the imported data, you will have to do these 4 things. Most frequently used word, that means frequency distributions of the word, bar chart, word cloud, and sentiment analysis. And there is the other thing, topic model. Those things could be done, but I did not discuss those things. Topic model means Barack Obama gave a speech. In entire his speech, he spoke about like 10 different topics: financial condition, unemployment, foreign policy, national policy, okay, defense, and like war. Understand? Each is a topic, so topic modeling. So that could be also done. Are you understanding? So I have given you the clue how to import the data by looking at this. So I give you permissions to work with you together for importing the data, and after importing the rest of the things, I have given you the code and everything. You just run one of the code and get the desired result. Okay, but make sure you are taking serious preparation for your exam. Okay. As it's a very easy exam, and I have given you all the materials. Data is different and variables is different. And if you are not familiar with all of this, you already submitted the homework, I graded, do it again and again and again. Okay, 2 hours 30 minutes, that means 150 minutes, you have to answer 30 questions. Okay. Okay, I'm going to stop in here if you do not have any question.